Just doing a quick sound check, guys, because my mic is slightly off. That sounds alright, doesn't it? Okay, so I did say we're going to do the 2016 paper, but I realized that halfway through I was copying the papers just about 10 minutes ago, and realized that we actually did quite a few of those questions, and so I kind of have to switch it last minute. So we're going to go with 2015. Basically, guys, today all we're doing is the 18 merit questions from 2015. So we're doing all of the merit questions pretty much today. That's all we're doing today. All right, so we're pretty much starting early today so that we can just keep chipping away at this. I've cleared my calendar for a couple of hours so that we could try and try and go through some of these older questions. But still, I mean, there's still like lots of variety in it, so we can kind of get through it. Haven't really thought about it tomorrow, Joseph, because generally speaking, like the day before exam, I really don't want to be sitting there doing tutorials, just because it just gets too stressful for people. So generally, I kind of like just keep it really simple. Like I just kind of point people where to go, like how I did for the level 1s and level 2s. Yeah, it's just like if I start teaching on the night before the exam, people just start freaking out a bit. They're like, oh, I don't know this, I gotta go do that. So yeah. When am I doing level 1 science? When I actually learn, I guess, a little bit of science stuff, Strike. Glad the TEG went good, Edward. I heard some really positive things from people about TEG. Yeah, like compared to last few years, it was actually really nice to hear some really good things about it. So this is going to be our first merit question. So we're going to be kicking off with complex numbers, guys. So what we'll do is we'll do like 6 questions of the merit, and then we'll take like a 5-minute break. And then after that, we'll come back and do the 6 differentiation questions, 5-minute break, and then 6 of the integration questions. I'm hoping that you guys can actually see the question. All right, so the time right now is 7:09, so I'm going to give you guys about, what do we need for this one? Yeah, I'm going to give you guys about 3 to 4 minutes on this, and then I'll go through the answer. How do you mean, Lou? I don't understand that. This is just during exam season, man. Like I'm pretty much go quiet mode in from like first half of the year, because I'm just kind of like chilling out for 6 months before actually getting ready for the season. No, Riley, we're doing this is the merit marathon. Welcome to the merit marathon, as we called it the other day. We're doing all 18 merit questions today from the 3 papers from 2015. So we'll start off with complex, and then we'll, like as I said, we'll take a 5-minute break and then come back differentiation, 5-minute break, and then finish off with integration. So we're going to do this for like a couple of hours, I'm thinking. Yeah, so just feel free to drop in and out, like it's no biggie. I mean, if you find one of the questions easy, then just kind of like go work on something else and then come back again when just to see where we're up to. Now, I haven't seen the paper yet, Edward. So once I have a look at it, it'll give me a bit of an idea. How are we going with this question, guys? You guys ready for me to go through the answer for this? Need a bit more time? Okay, another 1 minute, and then I'll actually go through the answer. As I said to you guys before, like even with these types of questions, you know, like have a crack at it, have a go, even if you don't know where you're going to go towards for the final answer. But getting somewhere halfway through is going to get you an achieved grade, which is still, you know, it's worth like 2 points, which makes a massive difference when it comes down to the cut score towards the end, right? I mean, like, yeah, with calculus, it's like usually 7 or 8 points to get an achieved, and you can kind of pick it off, do a little bit at the start, and p 0.5, negative 0.25. Nice, Joseph. Yeah, you're on the way there. Cool. I'll actually go through the question, guys. Just to bear with you guys in this, all right? Like, look, you can actually use the graphics calculator for this, but you got to be very careful because it's like when it comes to merit questions, ideally they want to see some sort of working, but you can actually, like I did with the integration and differentiation papers before, you kind of show them the working, but then really you just kind of use the calculator anyway to kind of solve it, right? So just something for you to keep in mind. Okay, so what we've got here is we've actually got v, which is 3 minus 7i, which I'm going to substitute into v there, and then w is negative 4 plus 6i, which I'm going to substitute into there. So what I've got here is, just going to zoom in a little bit. So I've got p3 minus 7i plus q times negative 4 plus 6i. All of that is equal to 6.5 minus 11i. Now the first part that I need to do is I actually need to expand these brackets here. So what's going to happen is I'm going to get 3p minus 7pi negative 4q plus 6qi is equal to 6.5 minus 11i. Now, interestingly enough, correct second line, just this expanding part here, yeah, this part right here is going to get you an achieved. Unknown, generally speaking, like I'd say 15 is a safe bet, but I know like 13, 14 is like you can get it, but like 15 guaranteed. You're gonna, if you answer 3 merit questions, you're gonna get 15 points, and that's why we're doing all the merit questions today, so you can kind of get the idea behind it, right? Cool. So now that we've got the achieve part here, next thing is actually collecting all the real values and then collecting all the imaginary values and putting them together. So what do I mean by? Let's see, my real value is 3p, 4q, and 6.5. My imaginary values are negative 7pi plus 6qi and negative 11i. So what I'm going to do is I'm going to write them as 2 sets of simultaneous equations. All the blue lines on one blue variables in one equation, and the pink one, which is imaginary, on the other on the second equation. So I'm going to end up with 3p minus 4q equals 6.5, and then on my second line I'm going to get negative 7p. Now I don't need to worry about the I because I know that all of them are imaginary. So I mean, if you think about it like this, right? So if I was to write it, negative 7pi plus 6qi equals negative 11i. Now the I is a common factor, which means I can take it out. And then I take the I to the other side, which means it's going to get divided by I, and then the 2 i's are going to cancel up. And so it's like I'm just saving saving a bit of time with that. All right, so I don't really need to write the all of this part. I don't really need to worry about writing it down. So once I get to this part here, which is in the red square, here's the thing. At this point, you can actually use your graphics calculator. All right, just put this in the graphics calculator and get what P and Q is, and you're pretty much done and dusted for this question. Because yeah, you don't really need to show working for simultaneous equations because that's what you did at level 1. So they assume that you already know simultaneous equations. Therefore, you can kind of just skip that straight and go straight into your graphics calculator to do this. So number of unknowns is 2, so we're going to put in 3, negative 4, 6.5, and then we're going to get negative 7, 6, and negative 11. So putting those two there, I'm going to get my values. So the first value was P, so P is equal to 0.5, and Q is equal to negative 1.25. And this right there is going to get you possibly one of, I think when I look back at these types of questions, it's like it's a simple little merit question compared to like some of the ones we're going to face later on. So as I said, like for the simultaneous equations part, you guys don't need to actually show the working. Just put that directly in the calculator and then like you're good to go. Yeah, Edward, it's, I mean, if you want to have a crack at it, man, there's a playlist I created called Mathematic Level 3. It's from video 2 onwards. You can go have a look in that playlist. You pretty much will get, I've been told that like guys that have went through that series, they've been getting either merits or excellences for complex numbers. All right, with you guys, any other questions? Any kind of niggling questions here, or are we ready to move on to the next merit question? Let me know. Cool. Okay, let's go to the next question. Now, this is a bit of an annoying merit question. And I remember it popped up in level 2, maybe in 2019, I think it was. Similar question like this. Cameron, this is 2015, mate. So we're just kind of like revisiting some old papers. Yeah, it is a discriminant question, but it's a weird discriminant question. I'll give you guys another few minutes because I think the you might be all right with getting up to the achieve part, but that merit part is just minor adjustments that you have to do to understand it. There is an element of completing the square in this. I'm just going to give you guys a heads up on it. I know it's out, Sahil, but I haven't had a chance to look at it yet because I actually had a nice weekend when I caught up with a few of my mates. So I probably will do earlier next year, man, because my brain is not, it just goes frying at this point. Because sometimes like, when I look at the papers, I just start annoyed. I get annoyed at it's like, why do they ask questions like this and stuff like that? Especially over the last few years, right? Like I've just been like, you kind of build up these, like I kind of work with all you guys over the last 3 years and like, get you guys ready for the exam. And then, you're thinking, all right, now, like in the morning I go out for a run and I'm like, yep, these guys are going to be all good. And then at about 11 o'clock, I start getting messages going, sir, that paper was just horrible. And I'm like, oh God, here we go again. But at least the level ones came back and said that the TEG paper wasn't too bad. So that was actually quite nice. They said that it was basically like a cut and paste of 2020. All right, guys. Do you guys need a bit more time for this, or shall I go through the answer for this one? Because I know this is not a straightforward merit question. It kind of asks a little bit extra. So I'm happy to kind of start kicking off it and just wait. All right, we'll have a go at this, all right? So this question here, first off, it's actually saying it's a proof question, right? So you're going to have to prove, and it says that the roots of the equation are always real. That means you've got roots. So we could potentially say that if the discriminant is positive, so basically what we want to try and prove is that the discriminant is always positive. You could put it always or equal to as well. Can you? No, you can't, because it's like roots of it. So discriminant has to be greater than 0. All right, that's what we're trying to prove. Now, if we look at the discriminant here, so let me just move that out first. So we want to prove that the discriminant is always positive, which actually tells us that we're going to have roots of the equation is always going to be real. Now, we're going to have our a values. So a is equal to 3, b is equal to 2c plus 1, and c is equal to negative, and I'm going to make sure I put that bracket around there, negative c plus 3. Now with that in mind, all I'm trying to show is that b squared minus 4ac is always got to be bigger than 0. All right, so that's pretty much all I'm doing here. So I'm going to calculate what b squared minus 4ac is. So I've got 2c plus 1 squared minus 4ac, so a is 3, and c is negative c plus 3. Now basically this two negatives here, when I multiply it, it's going to become positive. So I've got 2c plus 1 times 2c plus 1 plus 4 times 3 is 12. I'm going to get 12 times c plus 3. Now, just to give you guys an idea, just expanding this and actually bringing it to a single equation is going to get you an achieved. So that's what I mean by, like, in this question, if you're like unsure of like what to do, like think back, we're doing discriminants. We're looking for always real, which means we're going to have two solutions. So put it greater than 0 and then just kind of start chipping away at it. So here we've got 4c squared plus 4c plus 1 plus 12c plus 36. So all I've done is I've just expanded the brackets, and simplifying it, I've got 4c squared plus 16c plus 37. Now, this right here is going to get you guys an achieved, right? Because all you've done is you've basically put down b squared minus 4ac, and you're good to go. However, we now need to prove that this equation is always going to be positive. Now, what I want to show you guys is, let me actually show you guys what this graph actually looks like. I'm going to go into here. So we're working with 4c squared, so I'm going to put it as 4x squared. Okay. So if you guys have a look at this, like when we graph this, right, we can actually see that the parabola is actually above the x-axis, which means our values are always going to be positive. Now, the way we kind of have to do this, like the way we'd have to do it is we'd almost have to go back and do some sort of completing the square to try and actually prove that it is positive. So, and I know that some of you guys are like, oh, you think about completing the square and you start kind of like fiddling around a little bit, but it's not too bad, because all we're going to do here is we're going to take out the 4 as a common factor just for the c squared and the 16c, which means we're going to get c squared plus 4c like this, plus 37. Can you use GC for completing the square? I'm not sure. I really am not sure. Because, I mean, like, we're trying to do it into... I'm trying to think, man. I'm trying to think. Can we do it a cheeky way? Huh. This is me thinking on the spot. I don't know if it's going to work or not, but we could try it out. Okay, so see this button here, conics, right? Vertex. How do you find... actually, Jonathan, I think you might actually be onto something. Let me just try something here. How to complete the square? 4c squared plus 16c plus 37. Yeah, no, I think it's going to work. Let's try this out. So if I go 4x squared plus 16x plus 37, I just want to try this, all right? Because if this works, Jonathan, you might have just saved a lot of people a lot of time. Then it's already drawn up there. If I go, hang on, where is it? G-solve. This is a positive parabola. So if I go minimum, holy mother, okay. Jonathan, you are a legend, Jonathan, because I think you just saved these people a hell of a lot of time by asking that one little question, whether we could do this. Okay, so the hack is this. I've just kind of figured this out. I'm going to show you guys the long method, all right? The long method is going to be painful, but this is a bit of a hack, and trust me, it will work. So forget about the long method. I'm going to show you guys how to do this. If you guys get a quadratic and you want to complete the square, this is what you do. What you do is you go into the graph mode, and then what you can do is just type in that graph as it is. So notice how it's like mine is like 4c squared plus 16c plus 37. So all I've done is I've just put it as 4x squared plus 16x plus 37. Now, I know that the 4c squared, or 4x squared, is a parabola. The parabola is actually going to look like this. All right. Now remember, like this is going back to level 1. When you have a parabola, so we have a parabola right now, which is 4x squared plus 16x plus 37. Now we know that the a value is actually 4. All right. How do we know this? Because that is right there, the coefficient of x squared. Now what happens is when you draw this in the graphics calculator, you might not actually see your graph. So it's going to pop up like empty like this. All right. That's because the graph is like somewhere way up at the top. But what you can do is you can actually find out where the vertex is. So you click on G-solve, and instead of the vertex, it's the same thing as saying minimum, because remember that this point right here is the minimum point. So when I click on minimum, I'm going to get -2 and 21. So this right here is -2 and 21. Now if you remember, guys, we can actually write a parabola in a vertex form as well. The vertex form, all it's going to look like is this x plus 2 squared, because remember we've got to write the opposite of the x value, plus 21, and it's shifted up because that's what that y value does. And we already know what the a value is. The a value was 4, so there is our equation, which is actually completed the square, without you having to actually sit there kind of trying to complete the square and stuff it up. And I know I kind of rushed through that, but it's a really interesting way of, like, I'm glad you asked the question, Jonathan, because I hope that it actually made sense for you guys how I did it. Because if I showed you guys the answer, because all they've done is like from this step to this step, they've actually done completing the square. But what we've done is we've just drawn the parabola on the graphics calculator, got the vertex, and reverse reversed it. And hope that made sense. I might give you guys a couple of extra questions so that you guys can do it on the side before we move on to the next one. But anyway, going back to this question, what we now have is we can actually rewrite this as 4c plus 2 squared plus 21. Now, the important thing to notice is that we said that the discriminant has to be bigger than 0. And if you look at this number here, we've got c plus 2 squared. Now, anytime you take a number and you square it, it's always going to be positive. All right, so think about it like this. We've got 4c plus 2 squared plus 21. Now, c plus 2 squared is always going to be a positive number. Then we've got 4 times a positive number, which is also going to be a positive number. And then we've got positive number plus 21. It is going to be positive. So what you can say is, since c plus 2 squared is always positive, discriminant is greater than 0, therefore 2 roots. There's always going to be 2 roots. Yeah, that's going to go down. Like if I had like a little kind of like celebratory button or something like that, I can possibly say that was one of the coolest questions to kind of crack this. Like so many guys ask about completing the square, and I'm like, can you do it in the calculator? And I've never actually, like, it didn't click until you actually asked me the question, and I was like, and I drew that on that Desmos, and I'm like, hang on a minute, that's just a vertex form, just reversed. So there we go, people. Hopefully that helped. But look, what I might do is after this question, I'm just going to give you guys another completing the square question just to see how you guys go about it. And if you are comfortable with it, then you can just use the calculator and then you're already good to go. Just on question 1B, Joseph, but I would rewatch this or like just stick for the next 5 minutes because Jonathan here has just kind of helped us with completing the square real quickly. Any questions with this one, guys? Or shall we try a couple of quick completing the squares with your graphics calculator to see how we go? Yeah, I think it's a good idea because the thing is, remember in complex numbers, those excellence questions, when you guys get like a big massive conic and then you have to kind of like do how would that one work? Yeah, that would still work as well because you'd have x plus 2 squared and stuff like that. Yeah, definitely would work. Cool. I'll put up a couple of questions just for you guys to have a play around with completing the square. I mean, these are like really just punching it in the calculator and just working them out. So let's try something like x squared plus, try that, and then try something like this, 18x. Yeah, let's just try those 2 quick questions, all right? I'll have to add it to the calculator hacks playlist. I need to write that down somewhere so I don't forget. It's all right, Joseph. You just popped in now, right? So we'll go through it, mate. YouTube, where's my list? Video playlist. Okay, add. GC, complete the square. It's a little hack, but it should definitely work. Joseph, just draw it in the graphics calculator, get the vertex, and then once you get the vertex, you just need to rewrite the equation in vertex form, and that's completing the square. All right, so I'm going to do the question A, guys, because I know like we're mindful of time here at the moment. So what have we got? So I'm going to plot this one, which is going to be x squared plus 8x plus 10. So there's my parabola right now. I'm going to draw it. I'm going to click on G-solve. Now I know that that's a minimum, so I'm going to click on minimum. Lou, I wouldn't put that as equals 6, but rather minus 6, because it doesn't equal anything, all right? Cool, so there we go. That is my, what is it? It's my vertex for the first one. So the vertex is at -4 and -6. And also, if I look at the a value for this one, it's just 1. So I can rewrite this as x plus 4 squared minus 6. Now, Lou, this is an expression. It's not equal to 0. So keep that in mind. So you can't actually write equals 6. It's just you leave it as an expression like how I did in the blue underneath the question. So, and having a look at question B, guys. So what I'm going to do is, again, same thing. I'm going to go put in this equation. So I've got 3x squared plus 18x minus 20. I'm going to graph it. I don't know, well, I don't care what it looks like. I'm going to find the minimum, G-solve, and click on minimum. So it's -3 and -47. So my vertex is at -3 and -47. So that means my equation is going to look like this. X plus 3 squared minus 47. And because the a value is a 3, I'm just going to chuck that 3 in the front. And there's your completing the square done. Any questions, guys? Otherwise, we'll move on to the next lot of merit questions at question 2. With an inverted parabola, you just got to take the negative out. So let's try it out. I mean, you want to try an inverted parabola. Where is it? Okay, let's see what happens with the inverted parabola. So if we do something like -4x squared plus 8x, I'm going to try it out, right? Like, so we never know until we give things a crack. So plus 8x plus 9. Let's try this one. Let's just see what happens. Okay, so if I go -4x squared plus 8x, I'm sure there's got to be some sort of draw, G-solve. Oh, sorry. For inverted, it's going to be maximum, not minimum. So maximum is at 1 and 13. Let's see whether that actually works right. So vertex is at 1 and 13. So then my equation would be x minus 1 squared plus 13 -4. Those are what my two predictions are. Let me go try this out. Okay, I'm just going to switch over to the screen, guys. So the question you asked was -4x squared plus 8x plus 9. Is that the same thing as saying -4 x minus 1 squared plus 13? Yo, look, they match up. Yep, so Sam Clark absolutely works by the looks of it. So for an inverted parabola, all you got to do is just make sure you look for the max, get the vertex, and there you go. Works. I think that's you guys sorted for completing the square, guys. So Joseph, hopefully you picked that up, man. We'll move on, guys. We'll go to the actual exam questions now. Where are we up to? We're up to 2C now. There we go. Hang on, I just got to refresh this quickly, guys. Are we back yet? Yeah, we're back. Cool. Yeah, just a bit of a, I think my main comp is crashed, but it's all right. Oh, really? Didn't even realize that, man. I just kind of don't worry too much about it. Joseph, I think, I hope you got all of that. Oh, yep, looks like you said you got it, so you're good, man. Cool. We're going to go have a look at this one here, guys. So this is question 2C. Um, yeah, this is quite an interesting question, I have to say. I will. I'm going to give you guys like what 3 minutes to do this. Also, a clue for this question is if you're stuck and you're like, oh, I don't know where to start from. You want to have that. Notice how the left-hand side is one fraction, the right-hand side is three fractions separated. So you want to try and bring all those three fractions together on the right-hand side. That's your starting point. I'm gonna give you guys about, I'll give you guys about 3 minutes for this. Yeah, no, I can't. I'm still like every summer I'm like, this is the summer I'm gonna learn. This is the summer I'm gonna learn. And I keep putting it away, but it's come to a point where my kid is actually learning now, so I might just have to bite the bullet and learn. That's one of the reasons why I haven't done like what do you call those things? Like a mini triathlon yet. It's one of my things that I really want to do. But I need to learn how to swim first. That's a big hello, Dave. I'm glad you can join us, mate. Let me know how you guys going. If you want me to kind of like just start with a question, I'm happy to do that as well. I'm trying to think, is there a hack for this in the calculator? Because that would be super, super cool. Maybe not. Equations. All right, guys, I'm gonna start having a go at this question, just because like it is, you know, it's easy to forget it because when you look at it and you go, geez, what the hell am I supposed to solve this for? But basically, what's happening with this question is you've got three fractions that you've got to try and put together. All right. Now, if you look at the left-hand side, you've actually got x squared, x minus 1. So that's what I'm going to kind of put out here. Let me just see if this is going to work. And I'm going to kind of like start separating all of this a little bit. So I'm going to have a over x plus b over x squared plus c over x minus 1. Now, if you have a look at this, this is 2015 paper. If you have a look at this, what I want to do is I want to make sure that all the denominators are going to be the same as what it was on the left-hand side, which is x squared, x minus 1. So if you look at it, I'm going to do the c the C fraction first, just so you can kind of see what's happening. So we've already got x minus 1 here. But what we don't have is x squared. So that means I'm going to multiply by x squared in the denominator, which means I'm also going to multiply by x squared in the numerator. All right, so that's C done. Then I'm looking at b over x squared. Now, x squared is already there on the left-hand side, but what it doesn't have is x minus 1. So I'm going to multiply by x minus 1 in the denominator and x minus 1 in the numerator. So I'm hoping we're good so far. And then if you look at a over x, what's missing here is I've got to multiply x with another x to get x squared, and then also by x minus 1. So that means the numerator, I'm going to get x and x minus 1. So what I've now done is, if you look at the denominator of each of those fractions on the left-hand side, the right-hand side, they're all equal to x squared over, x squared times x minus 1. So now I'm going to look at the numerator only, because that means I don't have to worry about the denominator anymore. And I can just write the numerator as 1 is equal to a, x times x minus 1, plus b times x minus 1, plus cx squared. All right. I don't really need to worry about the denominator, because remember, if I do something like this, 7 over 10 is equal to 3 over 10 plus x over 10, this is the same thing as saying, like, well, let's just get rid of all the denominators, and you're going to get 7 is equal to 3 plus x. So that's pretty much what we're doing here. We've just gotten rid of that denominator completely, and we've got just the numerator left over. Now we need to expand the brackets. So we're going to get ax squared minus ax plus bx minus b plus cx squared. So all I've done there is I've just expanded each of the brackets for the a and b. That's all I've done. Now comes pretty much the same thing that we did earlier with the simultaneous equations in question 1a. Remember how we put all the real parts together and all the imaginary parts together? Pretty much we're going to do something like that here, except we're going to look at the coefficients of x squareds and coefficients of x. So if you think about it, on the left-hand side, I've only got 1, and on the right-hand side, I've got ax squared plus cx squared, and I also have plus bx minus ax, and then I have minus b by itself. So remember that on the left-hand side, I actually have no x squareds. So I can actually put that as 0x squared. And also, I don't have any x's, which means I could write that as 0x. So basically what I've done here is now I can look at the a plus c is actually going to equal to 0. b minus a is also going to equal to 0. Finally, you can see that c there, the negative b is by itself, which is the only thing without x attached to it, which means negative b is actually equal to 1. So that's the first thing we're going to write down. We're going to write down negative b is equal to positive 1. We've got a plus c is equal to 0. We also have b minus a is also equal to 0. So, I mean, from that point, it's just like substituting each of those values in. Because the first part is we figured out that b is equal to negative 1. And because b is equal to negative 1, we can say that negative 1 minus a is equal to 0. Rearranging this, we're going to get negative 1 is equal to positive a. Then we've got a plus c is equal to 0, so we can say negative 1 plus c is equal to 0, which means c is equal to positive 1. So correct second line is going to get you an achieved. So I'm looking at here. This part is going to get you an achieved, and then this part here is going to get you a merit. So I'll pause there, and if you guys have any questions, feel free to ask. But pretty much this question is all about collecting your like terms, matching them up, and yeah, pretty much just solving it after that. And if you guys are happy with it, then we can move on to the next question. Yeah, I think it's just that understanding the the common denominator. I think if you get the common denominator, then you're pretty much good to go after that. Yeah, they keep changing it up, and then sometimes they actually bring it back as well, which is really quite interesting. Like I know that they actually repeated it after a while. They kind of like repeat certain types of questions. Um, Brendan, you could do cross multiplication, but the problem with cross multiplication is you can end up getting like quite nasty equations. So that's why I tend to stay away from cross multiplication and look at like the lowest common multiple and then try and put them together. Now, I don't think this is going to take 10 minutes to bear. I think it'll take about, I reckon this is like, now that you've done it, if I give you another question like this, then you know what to do. So you kind of like just be off on your way, and that's going to take you like 5 minutes maybe, not more than that. But yeah, don't get into the habit of cross multiplying, because if you do cross multiplication, you're going to get like x cubed and some really funky looking numbers, and it's just going to get too messy too quickly. All right, let's go through question D next. So with this one, like I said to you guys, I know that we can punch this in the calculator straight away, and I'm going to do that for you, so you guys don't need to like be telling me the answers. So here's the thing. I'm already going to do this in the calculator, right? So we've got 4i7 minus I. 4i to the power of 7 minus I equals to that. That thing divided by 1 plus 2i equals that, and then squared of that equals that. So here's my answer. My answer is 3 plus 4i. We already know what the answer is. Your guys' job right now is to actually try and figure out how to do this without the calculator, because you've got to show the working for this case. But remember how I talked to you guys before and said that you can show the working, like you can kind of pretend that like you know what you're doing, but really you're going to still be using the calculator. So this question I'm only going to give you guys like 3 minutes, not more than that, and then I'll go through it. Yeah, so we'll go through it at about 8 o'clock. Ooh, that's going to be a lot of work, man. Yeah, you definitely got to do a conjugate, but I7 you can actually get rid of I7 straight away. But yeah, I'll give you guys 3 minutes to go through this, and then I'll actually work it out for you guys and give you guys some shortcuts along the way as well. Um, I'm not sure, Kevin. You might want to look at the working that I've done and see if you've done exactly the same thing. If you did, then it should be fine. Hamza, welcome to the Merit Marathon. So we are going to be doing all 3 papers, all merit questions today. No worries, Zubair. It's all good. I remember you, man. Zoe, I'm honestly, I've not actually thought about it, because it's some of those excellent questions can take like a long time. I think I'm just sticking to merits at the moment, and tomorrow I might just kind of like point out things to people. But yeah, I don't think we're gonna be sitting there doing excellence questions on the night before. Flynn, what you could do is you could actually put I to the power of 7 on your calculator and do that straight away in your calculator. I think when it's reset, it should be, see, like, I don't think it matters with complex mode, because like I'm on complex mode real, and it's still working out. So if you guys want to find out what I7 is, just put down Shift I to the power of 7, and then you should be good to go. You should get negative I. By the way, the I is Shift 0. I hope you guys are using the right I, not alpha I, because alpha I will not work. One component. Jeez, that's a hard one. They do a lot of proofs. They do locus questions. It's mixed, man. Like, it's kind of, can't really put like a particular skill on it, unfortunately. All right, guys, it's 8 o'clock, so I will have a crack at this question. So as I said to you guys, the first step you want to do is you want to get rid of the I7. So this part, what you can do is you can just do it straight in the calculator, because what you're really doing is just getting rid of the I7. So you can put that as I negative I, equals negative I. And you can't see anything right now. It's not, there we go. We're good. So I've just put I7 is equal to negative I. My calculator can only do I to the power of 2. Kevin, I don't know if you can try it here. Like, okay, look, if you forget how to do I7, then what you can do is you can actually rewrite this as I to the power of 6 times I to the power of 1. Because remember that, like, you know, I to the power of 6 is the same thing as saying I squared to the power of 3 times I, which means you're going to get negative 1 to the power of 3 times I. Finally, you're going to get negative I. So it's just that extra bit of working that I've done there, which you probably won't need, but just putting it out there. So then what we're going to have is we're going to have 4I. Sorry, is that negative 4I? Yeah, because it's 4 times negative I. Might just put that as negative 4I minus I divided by 1 plus 2I squared, which means I'm going to get negative 5I over 1 plus 2I squared. Now, this is the tip that I'm going to give you guys on how to actually hack this, all right? Instead of you trying to actually do all this big, long working. I would actually do this. I would go negative 5I divided by 1 plus 2I multiplied by 1 minus 2I, 1 minus 2I squared, like this. All right, because what I'm actually doing here is I'm going to do that negative 5I divided by 1 plus 2I in the calculator. But what I'm showing the marker is I'm actually doing multiplication by the conjugate. So because of that, I'm just going to put this directly in the calculator. I've got negative 5I. Oh, come on, can't get that I. Divided by 1 plus 2I. So that's negative 2 minus I. So I can write that like this, squared, and then I've got negative 2 minus I times negative 2 minus I, and I'm just going to put that again in the calculator. All right, I'm not going to sit here working all of this out by hand, because I've shown the working right there of how to do it. And that pretty much is going to get you guys a merit there. All right, so it's just learning how to use your calculator, but at the same time learning how to put enough of the working there so that you can actually get come away with a merit for that question. For achieved correct third line, where would I put it? If I would go this way, then I'll probably say getting that -2 minus I, yeah, I mean, you could do it earlier if you wanted to, Lou. But I just kept it to the last because I know that, yeah, it doesn't matter which way you do it. As long as you can square it, you're pretty much good to go. Any questions with that, guys? Yep. Thanks, Grace, for kind of helping Kevin out there. That appreciate it. Yeah, Venzia? Yeah, it will get uploaded. All the streams get uploaded, guys. I should know that by now. Are we okay with this question? Are we ready to move on to the next merit question? That's going to be question 3C. All right, I'll assume that we can move on. All right, here we go. This is the one of those common questions that just seems to keep coming back. Keeps coming back, and hopefully it comes back this year again. Because if this comes back, this is one of the easiest merit questions that you pop up with. Better not go bark, dog. I might have to go out to grab the dog very soon, guys. If it gets too loud, I apologize, but we've had some unwanted cats that have just been a pain in the butt for us. He's just doing his job, I guess. How would you do this one without trying to do long division? After these next two questions, Bowie. The next question should only take us like a few minutes, but this one's a little bit more annoying than the usual variety of these questions. Guys, I'm going to give you guys one more minute and then I'm going to go through this question, but I'm just trying to see if there's a shortcut way of doing this, but I'm to say I'm struggling a little bit with it. Apart from doing long division, I don't know how. Now the other two solutions are complex numbers. So yeah, but you got to show the working for this one, Jonathan. That's the problem. Yeah, I know what you're talking about. Yeah, you could put it in complex mode and get all the answers, but unfortunately it doesn't give us, yeah, it doesn't give us what we need. Yeah, minus 2, no, we can't do minus 2 plus I, because minus 2 is like, how do I say it? It's already a real number there. Trust me, Sam, like, that's all I kept hearing about on, when was it? Wednesday or Thursday? Anyway, let's have a crack at this, guys. So I guess the first step is that we got to figure out what the A value is, and then we got to try and find the other two solutions. Now, looking at W is minus 2, right? So because W is minus 2, wait, what's it? Just annoying me. So, all right, so because we've got W is equal to minus 2, we can say that if we substitute like minus 2 like in the equation, so in other words, f of negative 2 is equal to 0. So what we're going to do is we're going to substitute 3 negative 2 cubed plus a times negative 2 squared minus 3 times negative 2 plus 10. All of this is actually equal to 0. All right. So because of that, what I'm actually going to do is, again, like I could sit here, do this, do this all by manual if I want to, but you know what, like when we have a solver on our calculator, why not actually use it? All right, so we're going to go 3 times negative 2 to the power of, what do we got, 3 plus alpha a, you could use x, it doesn't matter, negative 2 squared is 4 minus plus 6 plus 10, all of this is equal to 0. On that and solve. So what we've got is a is equal to 2. Where is the solver? So you just click on menu, go into equation. Once you go to equation, you click on F3, which is solver, and that should pretty much sort you out for any kind of these kind of questions, right? So we've got our first factor. Now, what are the other two solutions? I'm going to try and kind of show you guys two ways of doing this, all right? We've got the first factor. The first factor is W plus 2. All right, now think about it like this. And this might actually help you because you don't actually have to do long division for this. You can do long division. You can do long division if you are comfortable with it. But if you're not okay with long division, then what you've got to do is something like this. We've got 3w cubed plus 2w squared minus 3w plus 10. All right. So what we're trying to do is, like, we're trying to do w plus 2 times another bracket, which is actually going to equal to this 3w cubed. So if you look at it like this, so we've got w times something here that's going to equal 3w cubed. So straight away we know that this is going to be 3w squared, because 3w squared times w is going to be 3w cubed. Now looking at that last value, we've got positive 2 times something in that bracket, which is going to equal positive 10. In this case, it's going to be plus 5. So that's good to go. Now we've just got to figure out what that middle term is. Now the middle term, remember, it's going to be something w. We don't know what it's going to be, but it's going to be something w. So if you think about it like this, so we've got w times this, whatever this item is, we don't know what that is, plus 2 times this is going to equal minus 3w. All right, so in other words, we can write it like this: w multiplied by whatever the question mark is, like we might actually put it as k for now, kw plus 2w is equal to minus 3w. Have I got that right? I just want to double check that, guys. Give me 1 second. Because The only thing that I don't have is, no, that's going to become W squared. Sorry, that's not right, because that's going to become W squared. I should do W times 5. Yeah, that's more like it, because then I'm going to get 5W plus 2, whatever that thing W is equal to. I don't know what that is. That's a question mark there. That's a question mark. So 2 times question mark W is equal to minus 3W is what I'm going to get. Yeah, I think that's what I'm trying to get at. But I'm trying to prove it in a way where what that question mark is. But I'm doing something wrong here. What am I doing wrong? I'm getting minus 4. Oh no, I am supposed to get minus 4. That's fine. So I've got 2 question W is equal to minus 3W minus 5W, which means I've got 2 question W, whatever that question mark is. I might just put that as K, for example, there. Sorry, guys. I know I was going to mess up this question here. I'm just going to put it K because I don't know what that is. So 2KW equals minus 8W. Then K is equal to negative 8W divided by 2W. So K is equal to negative 4. So this is equal to negative 4. So what I've got here is my W plus 2, and the other factor is 3W squared minus 4W plus 5. And I guess it's important to show that other factor, because once you show the other factor, then you can actually find the solutions. The other 2 solutions you can just put, now you can actually put it in the calculator under polynomial. Degree 2, what have we got? 3 minus 4 and 5. Now the problem is when I put this in the graphics calculator, I'm getting 0. That's because don't think my calculator, see, as you can see, complex mode is set to real. Just want to change it to A plus BI. Degree 2, and I'm going to try this again. So I've got 3 minus 4 and 5. Yeah, there's my answer there. So I've got point. So W is equal to negative 2. W is equal to 0.66 plus 1.10i, and then 0.66 minus 1.10i. Is there an easier way to find the 2 factors? Yes, Roseanne, you could do long division. I think that's the best way I would go about this question, because I tried to do it like the shortcut method. Cameron, it's probably best to show working, because I know we can put this in the 3rd degree polynomial. Don't get me wrong. Because, I mean, like, it's just easy, right? You just put that in there straight up and you're done. But knowing that it's a merit question, they're probably expecting you to show some sort of working for this. So I wouldn't just put it straight in the polynomial and just find it. Yeah, so if you were to do the long division method, right, like just to kind of give you guys a real quick rundown of long division. Again, it is a useful skill to have. So I'll just do a quick long division here. So I've got 3W squared times W is equal to 3W cubed plus 6W squared. Then I do subtraction. So I've got 3 minus 3 is 0, 2 minus 6 is negative 4, W squared minus 3W. And you can kind of see how this is working out already, because I need to go minus 4. So minus 4W is going to give me minus 4W squared minus 8W. And you can kind of see what's going to happen here. So I'm going minus and minus. Negative 3 minus minus 8 is 5W plus 10. So here I've got plus 5, and I've got 5W plus 10, and all of that is equal to 0. So yeah, you could do it the long division way if you want to as well. That's not a problem, but you know, like I said, pick whichever one is actually easy for you and go with it. Bowie solver doesn't work because solver only gives like one answer. As Cameron is saying, it only gives you one answer, so it's not going to work. You have to put that under polynomial third degree. So if I go back to the original equation, right, I can put this in polynomial third degree, and I can put my original equation, which was 3, 2, minus 3, and 10. And as you guys can see, it just pops up with 3 answers. Now, there's no way they're going to give you a merit for this if they actually kind of, you know, if you can just put it in the calculator. There's no way they're going to give you guys a merit for it. Given one of the factors is a complex numbers is a lot more easier because you can use conjugate of it to get the other root. So I have done like questions before. They are under the complex numbers tutorials, Roseanne, if you want to have a look at it, because I spent like pretty much one whole session in 2018 just focusing on these types of reverse questions. All right, guys, we're going to do our last question for complex numbers before we take a 5-minute breather. And this one, I'm only going to spend like a few minutes because, oh, actually, might be a bit more than a few minutes, but it's all right. We'll give this a crack and then we'll take a 5-minute break. And then we'll go with differentiation, guys. Can't see the top line. That's all right, you. No, big cats are back. No, Eric. The last time I did that was back in 2011, 10 years ago. Calculus formula sheet. Tanisha, you want to be looking, here's a clue for you guys if you're kind of like finding this a bit challenging, right there. The clue is right there. Like with these types of questions, if you ever see like root 3, 1, root 2, that means they want you guys to have a look at the formula sheet. All right, so if you ever see complex numbers and you're given the values of root 3, root 2, then go straight to the formula sheet and have a look at the special triangles. Because I think the first part that's tricky is writing this in polar form. Because once you get this in polar form, then it's like, you know, you're done. In like 3 steps, you're done with this question. All right, guys, I'm going to give you guys another half a minute, and then I'll go through the polar form version of it. And then we can actually go through the full question. All right, guys, we're going to go through this question here. And like I said, the first step is like to get the, what do you call it? Writing this in polar form, right? I think that's the trickiest part. Because if you, once you get that in polar form, gotta refresh, sorry. Once you write this in polar form, then it's pretty much easy job right there. So we've got a positive k value, so that's going to be k right there. And we've got square root of 3k. So basically it gives us a complex number that's looking like this. So here is what you need to do. So I'm going to kind of take this apart a little bit, all right? So I'm going to take it out to the open here. So all I've done here is created like a little triangle like this. Now the base of my triangle is k, and my height of my triangle is square root of 3k. So what did I mean by looking at the special triangles? So whenever you see the 1 and root 3 or root 2 and 1 and 1, like those kind of like square root numbers with your complex numbers, go straight to your, what do you call it? Your formula sheet and grab that special triangles. Because what you got here is pi over 3, which is the angle, which is 60 degrees, and you've got 1, root 3, and 2. So if you go back to the working here, what we're going to end up with is, because it's 1k and square root of 3k, our modulus is going to be 2k, and our argument is going to be pi over 3, or 60 degrees. So we can actually rewrite this now as z cubed equals to 2k cis 60 degrees. I think this is the most challenging part, because everything after this, it's like a bread and butter. It's just like a repeat of the same things. So our first root for z is going to be 2k to the power of 1/3 cis 60 divided by 3. So our first root is going to be 2k to the power of third cis 20 degrees. Now remember that we are actually looking at z cubed. Because we're looking at z cubed, all you got to do is just add 120 to each one of your roots, which means your second root is going to be 2k 1/3 cis 140, and your third root is going to be 2k to the power of 1/3 cis 260 degrees. And pretty much that gets you a merit right there for getting all of those three answers. Oh, sorry, Gershom. Just for the 2k, just go back to the special triangles there. So notice how this is like 1 and root 3 and 2. So I've literally just used that, but instead of, so where there's a 1, there was a 1k, square root of 3k, and that means my modulus is going to be 2k. Converting rectangular to polar, geez, like, the thing is, like, Sneha, most of the time, like when you're converting it, I'm trying to think, it's like I don't even use it. I just use the triangles all the time. How do we know it's 60 degrees? Because pi is equal to 180 degrees. Because if you look at the, see how this says pi over 3? Pi is equal to 180 degrees. So 180 divided by 3 is 60. And then you got pi divided by 6, which is 180 divided by 6 is 30. And if you look at the triangle below, because you know how that's 45 degrees, isosceles triangle. So 180 divided by 4 is 45 degrees right there. Now, Joseph, you got to use special triangles. Like the moment you see the root 3 or root 2, then you know you're doing something. And also isosceles triangle. Like sometimes they do this when sometimes they put a question like this as well. Like they'll do like z cubed is equal to p plus pi, for example. All right, if they do that, then you're looking at 45 degrees as your argument, because both in the triangle, both your base and your height is going to be p. So if I draw it like a triangle, this is going to be p and p. So that's going to be 45 degrees. And then the modulus is going to be square root of p squared plus p squared. Like, you're just finding the hypotenuse of that triangle. In this case, it's going to be 2p squared. So that's going to be square root of 2p squared. Or if you take the square root, then you're going to get square root of 2 times p, like that. Yeah, like in this one, I think for an achieved, you only needed one correct solution. Like just that first solution that's correct is going to get you an achieved. Right there. Or if you get all the 3 angles correct, but you got the argument, like the other parts wrong, then you can also get achieved for that as well. You'd be surprised, Caleb. You know, you answer 2 merit questions, you're going to walk away with 10 points. That's an easy achieve, man. And I think that there's, what was it in 2018? Like this question that I just did, I've got a whole video of it. Like, you go watch that, you'll nail this question. That's going to get you 5 points. And after that, all you got to do is like answer 1 more question to get an achieved. So, Caleb, I will not accept you getting a not achieved in this. I don't know who you are, but I'm just saying that. Joseph, the key thing is have a look at the triangles, all right? Like if they put like K's, like if they put a variable in there, then most likely they're going to use special triangles of 45 degrees. That's it. They're not going to use anything else because that's just me if they want to do like 1 and 3 like that. Roseanne, you can give the answer both in degrees or radians. I choose degrees because then I can just add it real quickly and just move on to the next question. All right, guys. So what we're gonna do is I'm realized that we've actually gone into 8:30, like an hour and 20 almost. So we're gonna take like I was gonna say 5 minutes, but we're gonna take a 3-minute break. And then after that we will come back to differentiation for this paper. I just need to grab a few things. Can I put a timer? Vengsia, to do that, you've got to go to your original menu. Like before you even come there, you can click on Shift Setup and go into complex mode and change it to A plus BI. Gershon, the reason I use pi over 3 is because that's where the origin is. Because pi over 6, because if you think about it, in the original question here, this is the argument I'm looking for, and that's 60 degrees. The 30 degrees is from the top corner. Take a 3-minute break. So what are we going to do? We're going to be back at, I already said 3 minutes before, so back at 8:35, guys. And we're going to do differentiation. Yep, sorry, muted. Thank you for the reminder. Should be back now. Cool. We're gonna go with this, guys, and I'm gonna speed it up at the moment because I'm gonna give you guys maybe like a couple of minutes to have a crack at it, and then I'm just gonna go straight into the question. All right. Just because I'm aware of the time and I don't want to kind of like go past 9:30. Just gonna be fun. I'm gonna try and smash the next 12 questions in 1 hour. Speed run it is. Speed run. What do you guys reckon? Should I just do a speed run or actually give you guys time to actually to have a go at it? Speed run, speed run. Oh, lovely, awesome. Okay, game on. Speed run it is. Speed run means I'm just gonna fly through these. You guys can have a look through it because I love speed run, man. Because this is like sometimes it gets boring, right? Like just sitting there waiting for you guys to do it. Yeah, cool, 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 cool. Okay, let's do this then. So what do we got here? We've got this particular function, and we've been asked to kind of prove that for what values is it actually increasing, right? So basically, the first kind of concept is this. Remember increasing? If it's increasing, then we've just got to kind of show f dash of x as to be greater than 0. All right, so first off, we're going to figure out what the gradient is. So for the gradient, 8x, when I differentiate 8x, I'm going to get, this is the annoying thing. I've got to get rid of that. I'm going to bring that 2x plus 1 to the numerator first. So I'm going to get 8x minus 3 plus 2 times x plus 1 to the power of negative 1. So if I do f dash of x, I'm going to get 8. And then what do I got? Minus 3 just disappears to 0. I've got negative 2 because I've got negative 1 times positive 2. So I might just do it like this. And then x plus 1 to the power of minus 2. Of course, don't forget to multiply by the differentiation of the bracket. Luckily, in this case, we don't have to worry about it. But like I said, always put down that extra 1 just in case. Boston tomorrow is just going to be like a quick little kind of guiding thing, man. Like I'm not running a tutorial tomorrow. So what we've got here is we've got 8 minus 2, and in the denominator we've got x plus 1 to the power of 2. Cool. With that in mind, what we're going to do is we're going to write down 8 minus 2 over x plus 1 squared is greater than 0. We're going to have to rearrange this. But what we could do though is I'm trying to think. Yeah, let's flip it. Shall we flip it? No, let's not flip it yet. Gonna have to move this here. So let's just rearrange this. So we're gonna get negative 2 over x plus 1 squared is greater than 0 minus 8. So when I get 0 minus 8, so I've got negative 2 over x plus 1 squared is greater than negative 8. I could cross multiply, so I'm going to cross multiply the x plus 1 squared, and then I'm going to divide by negative 8, and because I'm dividing by negative 8, I'll need to change the symbol to the other way, and I've got x plus 1 squared. So I'm just going to rewrite this as x plus 1 squared greater than 1 over 4. Cool. Then I'm just going to go square root it. So I've got x plus 1 squared greater than 1 over 4. Now remember, this is a thing that we used to do with back in level 1 and level 2, right? So we're actually going to put it in, we got to find the roots, and then we're going to try and actually work it out. So what you could do is, and this is the part you could actually use your calculator for. So go into graph mode, chuck in x plus 1 squared as one of the lines. So we're going to go x plus 1 squared as one of the lines. And then the other line, we're going to put it as a quarter, just quarter by itself. And there you go. You can kind of see the graph. And we've actually trying to figure out when is it greater than quarter. So what you could do is just find out what those 2 points are. So we're going to G-solve, get those intersect. First point is negative 1.5. So when x is less than negative 1.5, and your second point is when x is bigger than negative 0.5. So kind of just to reiterate that. So what we've got here is we've got the parabola. That's your x plus 1 squared. Then you've got the line, which is a quarter. And from the graphics calculator, we picked up these 2 points, which is negative 1.5 and 0.5. Yeah, you always flip the symbol when you're dividing by a negative number. So remember, I divided by negative 8. That's why I flipped that symbol there. And as for this question, we can look at our two zones. When is it bigger than a quarter? It's there, and it's there. So that's why we write x is less than negative 1.5 and x greater than negative 0.5. So grades-wise, you need both the points, guys, with the correct derivative to get a merit. To get an achieved, you just need the correct derivative. Yeah, I think it's just annoying more than long, but yeah. Cool. Any questions before we jump on to the next one? Speed run, speed run, speed run. Hi, Zenyath. Okay, next question. Okay. As I said to you, Jang, I can't do that today, man, because it's been done before. It's in one of the videos. I just can't remember which one. I think I did do it last year at some point. So it's if you have a look at my whiteboards, you might be able to find it quicker than the videos. So in my website, if you go to my website, let me just show you quickly. You'll find the link to, like, if you go to the website, like, see, it's all the whiteboards are there. Just have a look at the calculus ones, and it should be there somewhere, hopefully. Sorry, dude, like, yeah, just trying to get through these merit questions at the moment. All right, cool. See you later, Peter. You have a good one. Next up, what we've got is question D here. We've got to figure out what values of x is the tangent to the graph parallel to the x-axis, blah, blah, blah. Okay, so what do we've got? We've got some sort of graph here, and we want to find it parallel to the x-axis. If it's parallel to the x-axis, remember the x-axis looks like this, and if it's parallel, then the gradient is actually equal to 0. So all we've got to do is we've got to differentiate this function, put it equal to 0, and find out what the x values are. And yes, quotient rule, that's what we're going to be doing. So we've got f of x is x plus 4 divided by, I'm going to just expand it because it's easier, x squared minus 5x. Now, I'm going to put this as u as x plus 4, which means u dash is equal to 1, v is equal to x squared minus 5x, v dash is equal to 2x minus 5, which means f dash of x is u dash v minus uv dash divided by v squared. So putting this all together, I've got 1 times x plus 4 minus x, no, hang on, I've done something wrong here. 1 times x squared minus 5x, that's better, minus x plus 4 times 2x minus 5, and all of that is divided by v squared, which is x squared minus 5x squared. Now remember that the gradient is actually equal to 0, and because the gradient is equal to 0, as I said, because it's parallel to the x-axis is flat, straight like that. That means the gradient is 0. So we're going to put f dash of x is equal to 0. Therefore, 0 is equal to x squared minus 5x minus x plus 4 times 2x minus 5. All that divided by x squared minus 5x squared. Now, guys, another thing to remember is this. Whenever you have quotient rule and you're putting it equal, when you get the gradient is equal to 0, the part at the denominator might look super ugly, but don't worry about it, because when you take the denominator to the left-hand side, you're multiplying it by 0, so it's going to disappear anyway. All right, so in this case, when I actually bring this up to here, disappears, 0. So what we've got is, we've got 0 is equal to x squared minus 5x minus, now I just need to expand this bracket here, but I'm going to make sure I put the minus out for now. And I'm going to expand this bracket inside here, which is going to be 2x squared minus 5x plus 8x minus 20. Kind of keep working away. So I've got 0 x squared minus 5x, still keeping that minus outside. I've got 2x squared plus 3x minus 20. And then 0 is x squared minus 5x minus 2x squared. Let's see if I'm on the right path here. Yep, minus 3x plus 20. So we can simplify this now as negative x squared minus 8x plus 20. What we've got here is a lovely quadratic equation. So we're just going to put this straight in the calculator. We're not going to be sitting here doing, what do you call it, long quadratic formula or anything like that. Just go into polynomial degree 2. We've got minus 1, minus 8, 20. Get our two equations. So x is equal to 2 and minus 10. Walk away with, what are we getting? Merit grade for this. Correct derivative gets you an achieved there. So that's that. Doing the quotient rule is going to get you an achieved. Getting the two answers is going to get you a merit. Now the quotient rule always, as I said to you guys, and especially with, I've seen it with quotient rule with exponential, people start freaking out. But remember that when you actually take the denominator, like Lou said, it gone, man. Don't worry about it. So that is it for this question. How do we go with that? Too fast? Too slow? I'm just mindful of the time, guys, because it's just like if we, otherwise I need some sleep at some point as well. Yeah, because look, the way I see it is like, I mean, we started doing these two merit questions at 8:30, 8:35, I think it was. And if you look at it, even with the minimum amount of talking that I did, we've taken about 13 minutes for these two questions. And like, if you think about it, ideally you want to be doing these questions in like 10 minutes. So, but again, if you're aiming for excellence, if you're aiming for merit, yeah, it's all good. Like that's a good timing there. All right. Now question 2, guys, 2A. I didn't see it last year, but I've seen it like pretty much every year before that, which is really weird that I didn't see it last year. Now, I'm actually not going to do question 2C. I could do it real quickly. It's these ones here. Now, I actually ended up making, like in 2017, I think it was. Like if you guys go and have a look at my 2017 differentiation tutorial, there's one purely focused on limits, like this stuff. Yeah, you just got to watch it, man, because it's like I've covered all the questions, like every type of question that they could ask for. Now it tends to be merit, Joji, because they've got like about 5 or 6 questions. But if they actually end up with like 3 questions, then it'll be yeah. Then if it's like 3 questions, it'll be achieved. Yeah. Thank you, Andrea, for that, because yeah, that I'll actually find the video. Give me a second, and that way that calculus tutorials, full playlist limits. Yeah, so I won't actually go with this question, guys, because it's only an 18-minute video, but it pretty much covers everything you need for limits. So what I'll do is I'll just pin this for now. There we go. I learned this the other day. So I won't, because I think I did cover this question in that video as well. So, but it covers like a whole lot of it. Yeah, it's 20 minutes, but it's like you'll get it. And again, if you're like doing differentiation, and if you're like banking on a couple of questions, and if this question does come, it's an easy 5-pointer there for you. Yeah. So I won't actually do this one because, as I said, I'll put it on that video. We'll just go on to the next one here. And I'm more interested in doing this one because this one is actually worth the time that we're going to put in for this. Where are we at? Now, this type of merit question that pops up, right? Like rate of change questions. Rate of change questions, I always say this, like write down what you have, because usually they'll give you like one item, like that's the easy item that they'll give you, like we don't have to do any kind of working for it. The second one is you have to come up with a formula, like they're asking you for something, so that's like the second component of the equation. The third component of the equation is somewhere where you have to come up with an equation and manipulate that equation. All right, this is like your just your standard rate of change question. That's how all of them work. You'll be given something, they're asking for something, you've got to manipulate an equation to get that third component that you need to solve this. So this one I'm going to go a little bit slower, guys, because like when you get it, it just works flawlessly. And it's almost like a little light bulb that needs to go. And it took me like years for me to actually understand this, by the way. I would have to say, like, it wasn't until I started teaching calculus I went like, oh, that actually starts making sense now. But anyway, look, let's just gonna have a look at each of the information that's given to us, and we'll break this down one at a time. The first, no, Lou, don't think like that, man. Like, I mean, after that, I started teaching to people the way it kind of made it easy. It just, for me, it took, how to teach it, it took me that long. All right, so we got a street light that's 5 meters above ground, which is flat. So that's what we're gonna do first. That's your 5 meters. The boy is what, 1.5 meters tall, so that's 1.5. He is walking below the street light at 2 meters per second. And I think this is the first kind of information that we need. And we can actually say, so he's actually walking this way at 2 meters per second. All right. Now, the units is a big giveaway. All right, because it's meters per second. It's like the distance over time. We haven't figured out what distance, but basically we can say that like if we were to say this whole thing is walking 0.2 meters per second, walking away. So say, for example, if this is the distance, right, we can kind of say, I'm going to put this as S so that I don't get you guys confused with this, ds dt, could we say that? Maybe not all the way to the end, maybe up to here. So that could be written as like, that's 2 meters away. Sorry, 2 meters per second. So ds dt could be written as 2 meters per second. Now it says at what rate is the length of the shadow changing when the boy is 8 meters away from the point? So his shadow, maybe I should have used different letters, but it's all right. We're going to use the one in the schedule there. Well, actually, no, I'm going to use this W for shadow. All right, so that's his shadow right there from the W part. So they want to know at what rate is his shadow changing. So that right there could be written as, they were asking for what is dw dt when he is 8 meters away. So when he's 8 meters away means, what are we looking at? Yeah, 8 meters away from the point, directly under the light. It's interesting. I'm trying to figure out why we need that. Yeah, see, that's what I'm actually thinking. Now it is Revish. I know it's similar triangles for sure, but I'm just trying to figure out where they get that 8 meters from. Sick. This is actually an excellence question as well. It's not a merit question. Okay, no, that's all right. We'll kind of let's give this a go anyway. When we look at this triangle, we're going to put this as S. We're going to put this as W. We've got 5 and 1.5. What we've got here is a special triangle. Now, this is not a triple threat one, Jonathan. It's definitely not that. So we can write this as W over 1.5 is equal to W plus S over 5. So what I've done here is I've literally created similar triangles. So I've got this yellow triangle, and then I've got the green triangle. So with the yellow triangle, I'm doing base divided by height. So it's got the same ratio as the green triangle, which is the base divided by height. So that's all I've done there so far. All right. So once that's done, what we're going to do next is we're kind of going to rewrite this with W in terms of, or like we're going to write S in terms of W. But again, it doesn't matter which way you write it, because as long as you differentiate it, you're still going to end up with the same ratios anyway. So we're going to kind of cross multiply this. We're going to get 5W is equal to 1.5 W plus 5. So we've got 5W is equal to 1.5 W. What do we got? Plus S, sorry. Oh, I'm writing. So we can then write this as 5W minus 1.5W equals 1.5S. So we got 3.5W equals 1.5S. Yeah, but I get that S is 8, but it's like, I'm just trying to figure out, but it's almost like they, how does it work, man? How does it work with the 8? If it's similar triangles. It's all right. We'll just kind of figure this out. Let's see what happens after this. So we could write this as S is equal to 3.5. 3.5 divided by 1.5. So 3.5 W divided by 1.5. Yeah, I think that's what I was looking at, Revish, because I was like, what's with the 8? But then when X is 8, you still have to substitute X in there somewhere. But because we actually, how do I say this? How do I say this without trying to confuse you guys? The 8, we don't need to worry about the 8 because we've actually written the S in terms of the shadow. So that's why we don't need to actually worry about the 8, because it's just, all we have to do is, we don't have to worry about the 8 because we wrote it in terms of the shadow length. So that's why we don't need to worry about the 8. Basically what happens here is like we can write ds dw is then just going to be 3.5 divided by 1.5, or in this case it's going to be 7 over 3. Just bear with me, all right? Just bear with me, because this is not as tricky as what it looks like. It's just annoying, that's all. Now we want to find out what dw dt is, which means we can rewrite this as what do we got? ds. So we're going to flip this. So we could write that as dw ds times ds over dt. This is an excellence question, Dougal, but it's actually it's not, it's just the similar triangles. Once you get that similar triangle right, it's pretty much like an easy little question. So dw ds, all that is 3 over 7. ds dt is, we already had that right at the start, which was 2. So dw dt is just 6/7 meters per second. Really, really strange excellence question, because it's almost like we don't need to use that 8 at all because of the similar triangles. Because of the similar triangles, we don't have to worry about the 8. We wrote the shadow's length in proportion with the distance that he's away from in this equation right here, when we wrote down s equals to 3.5 w over 1.5. Yeah, stupidly annoying question. Yeah, but you know, the weird thing is like it's an excellence question, like, but in terms of the working out, it's like, geez. I think that, Luca, I get a feeling that it's just to throw you off, because I was like sitting there trying to figure out, why would I need the 8? Yeah, Roseanne, you can pretty much use this for similar triangle questions, because it's, if you think about it, right, like, even though the what's another way we could do this? The other way you could do this is you could actually figure out what S as 8, but then you'd have to figure out what L is. But again, we don't need to do that, because we've written the equation of how far he's from in relation to the shadow. Like, that's what that equation in the round bubble means. It's basically the shadow's length given how far he's actually from that. So I don't think it would actually make any sense to use the 8 at all in this question. Wow, Riley, this is yeah, I think I did a session on similar triangles for level 2s last week, maybe early last week, or even the level 1 geometry guys I did similar triangles with. So you do need similar triangles, guys, if you're doing any of the merit or excellence questions. They do pop up every now and then, James. So it's worth having a quick look at. But it's just understanding how the ratios work, and if you understand how the ratios work, then you're pretty much good to go. But it's literally something that just keeps popping back up and again. Yeah, Joseph, that's pretty much the idea. You know, the yellow triangle is similar to the green triangle, so that basically means that you can write base divided by height. The ratio of base divided by height is equal to the same ratio for base divided by height. So if you guys look at it, that's what I did here. So the W is, damn. So the W ends up being here, divided by 1.5 ends up being here. It's the same ratio as this whole thing, which is W plus S, divided by 5 there. It's that ratio there. Yep, you could do that as well, Zubair. So you could have done ratio of height divided by base as well. That's the beauty of similar triangles. It doesn't matter which one you do. So you could have written it like this as well. So you could have also had 5 divided by S plus W equals 1.5 divided by W. So you can write it in like as many combinations as you want in this. All right, there's as long as you follow the same ratio, then you're fine. So you can't do base divided by height equals to height divided by base. So you have to match the sides always. And if you match the sides, then that similar triangle is done. Now, I think this was one of those weird questions that they did where they had like a double excellence question, Isaiah, one of those years. But anyway, we'll move on to the next one, guys. Jang, I think Jang, if you're still here, Jang, you were asking about doing question 2E. You will have to use, if I'm correct, you might have to use some sort of similar triangles for that as well. Just to, hopefully that gives you a little bit of a tip there, man, to try and do that. Yeah, but we'll see if I get some time. Otherwise, I'll come back to it sometime later. C, this is 3C, guys. Doing differential equations. I think it is differential equations, is it? 3C. The hell? Wait, this is not differential equation. Whoa, 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 hold on. I've lost some questions. That is actually integration. There we go. Yeah, that one there, 3C, guys. Let's try that one. Yeah, sorry, Lou. I put the papers and I mixed it up. Parametric equations, guys, they do come up as well. And again, remember that your parametric equations are actually given in your formula sheet. Here we go. This is super useful, especially when you're doing the second derivative for parametric equation. Just go and grab the formula, substitute it, and then you should be pretty much good to go here. So for this question, what we've asked to find is we've been given a curve. We've been given x and y, and we've been asked to figure out what the gradient at pi over 4 is. So all we've got to do is differentiate both of those x and y, put it into dy dx, and you're pretty much good to go. Now remember, parametric equation also, it's very similar to, it's kind of like your base for rate of change questions. Because if you think about it, right, with parametric equations, you're going dy dx is equal to dy dt multiplied by dt dx. So you got to find dx dt and then flip it upside down. So what we've got is x is equal to 3 cos t, which means dx dt is equal to negative 3 sine t. Y is equal to sine 3t. dy dt is going to be cos 3t. But of course, this has got a 3t inside of it. So you got to multiply by the differentiation of 3t, which is 3, which people always forget about. All right. So whenever you see that, always multiply by the differentiation of whatever's inside the bracket. I didn't do it the first time for the x version because differentiation of t is just 1. And if you want good practice, just kind of keep doing that as practice. So we've been asked to find the gradient of the normal. All right. So we've got to find what the gradient is and then flip it by -1 over the gradient to get for the normal one. So we're going to work out f dash of pi over 4. Now what we've got is dy dt. So dy dt is 3 cos 3t multiplied by dt over dx. So that's going to be 1 over negative 3 sine t. So we can rewrite this as 3 and 3 cancel out. I've got negative cos 3t over sine t. So at this point, all I'm doing is just substituting pi over 4 because that's what the t is equal to pi over 4. So I've got negative cos 3 pi over 4 divided by sine of pi over 4. So putting this in the calculator, a little bit of tips for you guys, just so that, yep, that's fine, Zubair, you can do it. Joji, I wouldn't need to change the sign of the powers. You just kind of flip it upside down and leave it as it is. Yes, and you can also do negative on the sign there, Zubair, that's not a problem. So instead of putting pi over 4, what I'm going to do is I'm just going to put pi over 4 first. And I'm going to store that as my answer. Then I've got negative cos minus cos 3 pi over 4, so 3 times answer, divided by sine of answer. Because I put answer as pi over 4, then I'm going to get gradient is equal to 1. Now because gradient is equal to 1, gradient of normal is going to be -1 divided by 1, which equals to -1. So yeah, the final answer of -1 is going to get you a merit. Achieved is either getting this correct or getting this correct. One of the dx dt or the dy dt correct. What is it cos? It's just the negative 3 divided by negative 3. So all I've done is I've just shifted that negative sign to the numerator, Joseph, in here. So notice how it's 3 divided by negative 3. So the two 3's cancel out each other, and negative 1 just comes at the top. Yeah. Negative 73. Luke, you might want to check your calculator to see if it's in radians or degrees. But even then, it shouldn't give you such a crazy answer. So Gershom, if it asks you, that's not good. Hang on. We're good. Yeah, if it asks you for the equation of the normal, then you just need to put it back in the equation of a straight line, which is y minus y1 equals m times x minus x1. James, whenever you want to find the normal gradient, you might have done it last year with coordinate geometry, like where when you multiply two gradients, they have to equal -1, so that makes it perpendicular. So if you have m, they say that the normal of that is just going to be -1 over m. So that's all I've done there. If we're good, guys, I'm moving on to the next question. Now, y1 and x1 is like usually a point that's given to you. So remember how it says t is equal to pi over 4, right? Then your x value is going to be 3 cos pi over 4. So that's your x1. And then your y1 is going to be sine 3 pi over 4. So that's how you get those two x and y points. Because remember, they said when t is equal to pi over 4. So if they ask you for equation at t is equal to pi over 4, then you've actually got to get the x and y values for pi over 4 first. Then you substitute it into the equation of a straight line. Okay, so we are shifting to the next question, guys. The last question for differentiation, which is a painful question, but actually it's not too bad. Okay, so with this question, what they've done is they've actually given you guys this fact here, right? The equation, blah, 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 whatever, this differential equation. Now, what they're saying is this, and this is really important that you guys read through the question here, because it says, show that x equals to this is a solution of the equation of motion, because all they're asking to do is, they're just asking you to differentiate this equation twice. Because if you look at this whole function is x is equal to. Here, you've got d squared x dt squared. So all you got to do is you got to take x and you've got to differentiate it twice. So we've got x is equal to a cos kt plus b sine kt. So differentiating it once, I'm going to get dx dt. So cos, when I differentiate cos, I'm going to get negative sine. So this is going to become negative a sine kt multiplied by the differentiation of kt, which is k, plus b cos kt multiplied by the differentiation of k again. So that's what my dx dt is. So I'm going to do it a second time. What's going to happen now is negative sine is going to differentiate to negative cos. So I've got negative a cos kt, and this k is still from the original part that I did right there. Once again, I got to multiply by the differentiation of k. B cos, so that's going to become negative sine. So it's negative b sine kt times k, which is the original k. And I've got to multiply by the differentiation of this, which is another k. So simplifying this, we've got negative a k squared cos kt minus negative k squared b sine kt. Now you're trying to prove that this line is actually equal to here. And I guess the clue for you is the negative k squared. Because if you think about it, there is a negative k squared right there. We've got a negative k squared here, and we've got a negative k squared here. So we can actually take out negative k squared as a common factor. And what you're going to end up with is negative k squared multiplied by a cos kt plus b sine kt. And because this part right here is already equal to x, we can replace this with negative k squared x. And that's pretty much what you needed to do for part 1 of this question. Let me know if there's any questions, guys. Cool. And for part 2 of this question, so this is looking at, and I know like sometimes we go, why is kinematics and differentiation? But it's like, you know, when you differentiate displacement, you're going to get velocity. When you differentiate velocity, you're going to get acceleration. So in this, it says the particle was initially at the origin. All right. So if it's at the origin, then we can almost say that when x of 0 is actually equal to 0. So we're going to substitute that in the original equation. So we've got a cos k times 0 plus b sine k times 0. We're going to get 0 is equal to a times cos of 0 is just 1. And then sine of 0 is 0. So 0 times b is 0. So our first value, a, is equal to 0. Now the second thing it also says is moving with velocity 2k. So when we differentiate, so in other words, it says x dash of 0 is equal to 2k. Because remember, x is displacement. How do you know to double derivative? This is right here. See how the green highlighted part says d squared x over dt squared? That's how I know that I needed to differentiate it twice. So the second part is the differentiation of zero. Like I'm looking at, where am I looking at? I'm looking at this equation now for this part, because dx dt is the same thing as saying x dash. So I can say that negative a sine k times 0 times k plus b cos k times 0 times k is equal to 2k. So with that in mind, I've got sine 0, which is just the whole thing is going to end up being 0. And I've got cos 0, which equals to 1. So I'm going to get bk is equal to 2k. Therefore, b is equal to 2. Bit of a strange question because, yeah, like I think, Lou, you're right. Like I've not seen a question like that in a while, but it's just a bit of a, like a, it's to get both parts, you need to get both parts, part A and part B, correct to get a merit. But for achieved, you can get an achieved right there, that first line. Here's where you get an achieved. But for merit, you got to do both parts of it. Yeah, that is an annoying question, eh? Like, it's not like it's just the differentiation part is all right, but it's trying to understand that, like, they're mixing up velocity and displacement, and differentiation is just a little bit trickier. Right, I failed miserably trying to finish that paper in like half an hour. Yeah, let's just go straight to integration, guys. We're gonna have like a 1-minute break. I need a water refill, and then we'll go straight into integration. No worries, Joseph. Good luck, man. Tomorrow, well, I think Tuesday. Good luck for it. All right, let's go through integration. I think I left that question up at the top somewhere. There we go. All right, guys. Now, with integration, this particular question just keeps coming every year, right? Like even in 2020, comes up again. And I think we did this in our last tutorial on integration. I think maybe on Thursday night we did this question, similar to this question. So basic idea is when you see a differential equation like this, bring all the y's to one side, bring all the x's to one side, integrate, substitute to find out what the c value is, and you're done. Easy merit question right there. So we're going to cross multiply here first, which means we're going to end up with 4y dy equals e to the power of 2x dx. Integrate both sides. So we're going to get 4y squared over 2 equals e to the power of 2x. Of course, don't forget to divide by the differentiation of whatever 2x is, which is 2. And of course, also don't forget the plus c. Now people ask me like, look, do I need to put c on both sides? No, you only put c on one side, because remember, if you have two constants on both sides, when you bring one constant to the other side, a constant plus a constant is still a constant. So that's why we only use one constant and don't really worry about the constant on the y side of things. So we're going to end up with 2y squared is equal to e to the power of 2x over 2 plus c. Now we just need to substitute this part right here. It says when x is equal to 0, y is equal to 4. So we're going to get 4 squared equals e to the power of 2 times 0 over 2 plus c. Just going to kind of like solve this quickly. So 4 squared, that's 32. E to the power of 0 is just 1. So we got half plus c, so we can rewrite this as c is 31.5. Yep, Dougal, you can put it on any side, it doesn't really matter. You're still going to end up with the same number. All right, so once we get that c value, now we want to try and figure out what the 2y squared equals e to the power of 2x over 2 plus 31.5. We've got x equals to 2. So we're going to write this as 2y squared equals e to the power of 4 over 2 plus 31.5. Y squared is equal to e to the power of 4 over 2 plus 31.5, the whole thing divided by 2, and y is equal to square root of that. Yeah, it's not a bad question, just a little bit of extra working in there. But yeah, let's just kind of do that real quickly. Eh? So we've got e to the power of 4. I can't even see it now. E to the power of 4. We got that divided by 2 equals that, plus 31.5 equals that, divided by 2 equals that, and square root of that gives us 5.42, guys. That is a lovely merit question there. To get an achieved, you need correct integral of both sides, so you're probably looking at this line right here to get an achieved. Let me know if I can move on to the next one. Ooh, I know I've told people before that you could leave your answer as E values. So yeah, like this is like a lots of calculation in there. Like for example, if you had left it like this, E4 over 2 plus 63 over 2, E4 plus 63 over 2, and then if you divide it by 2, that becomes 4. So you could have left your answer like this, and I think that would be okay. Or even like square root of e to the power of 4 over 63 over 2. Like, I think that would be all right, but I wouldn't put like a fraction inside a fraction. Integration generally is around 7 or 8. Yeah, all of them are up to like 7 or 8, unless they changed it again, which I don't know. All right, question D, guys. We're going to question D, which is kind of like lost somewhere in the middle. Here we go. So with this question, we've got to actually, like every time I go through this, it's like I always end up going, yeah, we've got to use long division for this, because unless Jonathan asks me a question which kind of triggers in my head here of getting a shortcut, I actually can't remember. Yeah, Roseanne, you can give with the E answer, but like the other thing that you could also do, Roseanne, is you could do that the whole line in the graphics calculator. So you could have done something like this. You could have gone into equation, go into solver, and I think it was, what was it? 2, let me just grab that question. So we had 2y squared. So 2 alpha y, where's alpha y? Alpha squared is equal to, what do we have? 0.5 times e to the power of, what was it? 4, e to the power of 4 plus 31.5. So you could do it like this as well. So you could have put that whole equation in the solver and just get the y value from there, which is 5.42. Instead of rewriting all of that as Like, you know how we did all that calculation? You could have just done that one line and then just substitute in the calculator to solve it. Cool. So with this question, what we've got to do is, look, we've got to split this up into, like, doing long division is what I do. And if you guys know another method that works for you, stick with it. So all I've got is just 5. So I've got 5 times x, which is 5x. 5 times 3 is 15. And I've got to make sure I subtract everything. And what I'm left with is negative 3 minus 15 is negative 18. So what generally happens is I can rewrite this as 5x minus 3, x plus 3, and this is between 5 and 2. So I want it between 5 and 2, but except this time I'm going to write it as 5 minus 18 over x plus 3 dx. No worries, man. Like, yeah, I saw your comment earlier, so I was happy to help. Cool. Once we get this, we're just going to integrate it. So we've got 5x minus 18 ln of x plus 3, and that's between 5 and 2. So really important, guys. Like this part right here, you can sit there, you could actually write it all out and calculate it. But to be honest, this is all the amount of working that I actually show in this. Yeah, true. That's a good point. Divide 1 to just be safe. So divide by the differentiation of x plus 3. Like for this question, like, look, honestly, this is how much working I do. I go 5 times 5 minus 18 ln of 5 plus 3 minus, like, I do all of this, but when it actually comes to calculating it, I'm going to show you guys the shortcut of how to get the correct answer without having to do all of this working. All right. It depends, hydrotic. Like in this question, I'm going to use the calculator to solve this. All right, so I'm going to go into option, calculus, integral. What's my equation? 5x minus 3 divided by x plus 3. And I'm looking between 2 and 5. So there's my answer, 6.54. So what I'm trying to tell you guys is this. Like when you do these integration questions, right? Like just solve it. Before you even integrate, before you even do anything, just do the bit in the calculator first, get the answer, and then do all of your working. Right at the end, put equals, put 6.54, and you're pretty much good to go. All right, so these types of questions, especially with integration, and you're trying to find area under the curve, just do it this way because you're going to save a lot of time. You are going to pretty much kind of like just nail this because you know you're going to get the right answer by putting in the calculator, but you're also showing the marker that, here's my working, but I'm just not going to show you how I got from, like, I don't need to show you how I got from this line to this line. I can just do that in the calculator straight away. Thanks for the shout out, Pix. Really appreciate it, man. It's really cool when people come back and just give these guys a bit of a pep talk. Really appreciate it, man. Cheers. Cool. So we're done with this question, guys. 1D. We're now going to, oh man, not one of these long ass questions, is it? All right, so we're going to go into kinematics by the looks of it with question C. No, Maliha, you can't. You can't split it like that, Maliha. Please don't do that every time something. We used to have a little joke about it, but yeah, not anymore. That's like saying when you do this, Maliha, you can't actually do this. When you have x plus y squared, you can't write this as x squared plus y squared. That's actually incorrect. So similar principle for square root of x plus y. All right, guys. So what do we have in here? In this equation, we've got dv dt Uh, Achieved, Paul. Achieved. They're all what achieved. Simpsons and trapezium rule. I mean, all you're doing for those questions is just like substituting the values and solving it, which is like the longest amount of work you'll do for an achieved. Like I remember a couple of years when I've done merit questions like faster than putting Simpson's rule in the calculator to get it right. So anyway, guys, with this question, what we've got dv dt, which actually is acceleration. They say if the original velocity of the object was 6, so that means when t is equal to 0, velocity is equal to 6. Find the velocity when t is equal to 4. So they want to find out v of 4. So all we're really doing is just integrating, finding what that c value, well, we've already got what the c value is because it's 6, but then just substituting for 4. So let's try and work it out. So we've got acceleration is, I'm going to separate the denominator to 5t to the power of half minus at root t, 5 root t. I'll AKT. I think it's coming next, Tanisha. The next question is with differential equations, something very similar to that. So we're going to do that right after this question, all right? So we're going to cancel the 2 square root of t's. What we've got here is 50 divided by 5 is 10. 2 minus half is 1.5. Minus 80 divided by 5 is 16. Okay, with that, that's your acceleration formula. So velocity formula is now going to be integration of this. So we're going to get 10t, 1.5 plus 1 is 2.5, divided by the new power, which is 2.5, minus 16t plus c. 10 divided by 2.5 is going to be 4. So we got 4t 2.5 minus 16t plus c. Now remember that it said when t is equal to 0, v is equal to 16. So then we can just rewrite our equation as 4t 2.5 minus 16t plus 16. Zazi's, I pretty much I agree with Zazie, what Zazie said about it for Roseanne. Like, it's, yeah, if you're trying more than achieved, if you're trying for anything more than achieved, it's going to be like a lot of time to actually, you'll be spending a lot of time on trapezium and Simpson's rule, and it's like, when I look at the merit questions that you need to do, yeah, it won't be worth it. It'll be a bit of a waste of time with that one. Anyway, look, we got velocity, so we're trying to find velocity of, oh yeah, sorry, that's got distracted. Cats are back, but I'll do this question quickly, and then I'm gonna go bring the dog back in. So we got 4 times 4 to the power of 2.5 minus 16 times 4 plus 6. 4 times 4 to the power of 2.5 minus 64 plus 16. Okay, why does it give me, what did I do wrong here? Am I doing something wrong here? Because the answer says 70. you guys get 70 or 80? Yeah, that's fine. That's a mistake there. How did I get 80? What did I make a mistake with? Oh, I did the same thing again. Jeez. Ah, my goodness. Yeah, you're right. Yep, thank you, thank you, thank you, thank you. How long have we been going for? Just over 2 hours. There we go. Powers are waning right now. Hang on. I'll go get the dog. He's gonna go nuts. I'll put up the next question, and then I'll go bring him in. Now, this is the, what do you call it? I think somebody asked for this question earlier, but I'm gonna go bring him in. But you guys have a look through it, and I'll come back and I'll work on this one. Cool point. Okay. All right, guys. So we're gonna go through this question. I managed to get him in, but he might run off again. If he does, I might have to run off and get him again. But other than that, we'll have a crack at this question very shortly. Okay, you gonna be quiet? All right. Yeah. Wait. Hey, bed. Bed. Wait. Put it back. Watson. He's a handful, man. It's just we've got some freaking this one. Okay, let's actually go through this. So guys, I think what was it? One of the questions, the differential equation questions, like they kind of put I'm just trying to think. Why are you getting a syntax error there, Loof? I don't know what you're trying to integrate to get syntax error. Anyway, guys, look, let's actually finish this question. Don't integrate, like, how do I say it? Don't put the original function, Lou. Don't put like the integrated function. So what I mean by is like, look, in the original, like I put the original function, I don't put the integrated function. So going to this question, guys, the first thing you want to know is that when you have like a population that's like the classic, one of these questions that they do is basically like this. It goes dp dt equals kp. Check your brackets there, Lou, and check your brackets and check your commas to see if it actually works. So this is pretty much your starting point for this kind of like AEKT questions, where you put down something like this. Then what it says is at the start of 2000, population is at 12,000, and start of 2010 is that, right? So you're trying to solve the equation at the start of 2025. So basically the first thing you want to be doing is you want to actually integrate this. So to integrate this, we're going to bring p to this side and leave k on the other side, and we're going to write this as dt, kdt. Now if you guys attended the tutorial on Monday, we talked about this. It's like they're always going to end up being, in this case it's going to become ln of p, and then on this case it's going to become kt plus c, which means we can rewrite this as p is equal to ekt plus c. Now remember with exponential like indices rules, like when you add two powers, the two bases are the same. So you could rewrite this as p is equal to e to the power of c multiplied by e to the power of kt. And finally, we can actually say e to the power of c is a constant, so we can actually rewrite this as aekt. Now this part in the red box is your standard bread and butter differential equation question. All right, that's the AEKT one. It's like you just need to know that so that you can actually rearrange your equation, whatever differential equation you get, you rearrange it and you get it to P is equal to AEKT. Now what we're also going to do is we're going to put down a couple of things here. We're going to put down T is equal to 0, population is equal to 12,000. When T is equal to 10, population is equal to 16,000. Right, okay, so dp over p equals k dt, right? So what I did was I put it as 1 over p dp and then k dt. Now remember 1 over p is when you integrate 1 over p, you're going to get ln of p. And when you integrate k, you're going to get kt, but there's also a constant at the end. So hopefully that made sense, Jonathan, how I got that line. It's just I skipped like a couple of lines there. Nah, see the weird thing, Sam, is that you've actually got to show even though we know what it is, you still got to show the differentiation part of it. Because, Oliver, I'll come back to your question in a second. Sam, like this question can be done at level 2 using exponential equations. Because you know how we did that interest, kind of like you find the rate at which it's increasing in? Pretty much the same kind of idea you could use, and you can actually get this. Now, to come back to what the A is, the A is, yeah, as Pick said, it's actually e to the power of c, but it's also the starting value. So in this case, what's going to happen is A is when t is equal to 0, whatever p is, then that's what A actually becomes. So in other words, we're going to rewrite this equation as p is equal to 12,000 EKT. All right, so that's what that A value ends up being, Oliver. It's just whatever your initial population is, that's what your A value is. If you ever forget it, remember A is the first letter of the alphabet, so that's like right at the beginning. So that's what they're talking about. When T is equal to 0, that's the initial population at 12,000. That's how we know A is equal to 12,000. Now the question's asking us, what is the population at 2025? Now we know that when t is equal to 10, we know that it's equal to 16,000. So we're going to put that in here to figure out what our k value is. So t is equal to 10, p is equal to 16,000. So we've got 16,000 is equal to 12,000 e to the power of k times 10. So 16 divided by 12, which is 4/3. So I can just kind of do that quickly here. Can I write it as a shortcut? No, I can't, because that's just going to be 4/3 equals e to the power of 10k. How did I get 4/3? Because that's the 16,000 divided by 12,000 is 4/3. Then I take logs of both sides. So ln of 4 over 3 equals ln of e to the power of 10k. When I do ln and e, they just cancel out each other. I've got 10k is equal to ln of 4 over 3, which means k is equal to ln of 4 over 3 divided by 10. So ln of 4 divided by 3 divided by 10 is giving me 0.0288. So my population is equal to 12,000 e to the power of 0.0288 t. So when t is equal to 25, p is equal to 12,000 e 0.0288 times 25. So I'm just going to leave this decimal here. So times it by 25, I'm going to get that. So I've got 12,000 multiplied by shift E of answer is going to give me 24,600. Yeah, it's a little bit off, but that's all right. Now, because I didn't actually round that number, I'm going to get 633. And I know in the answer schedule it actually says 653. That's because they used the rounded value, and we didn't. Yes, Tanishka, K is just like a rate. So, you know, you could use any other letters if you want, but generally they use K for that, for the exponential equations. Brendan, K is a constant, but we still got to figure out what that constant is to try and solve for when the time is 25 years later, what the population is. So we still need to figure out what that K is. Happy to help, Smongel. See you for the next 2 years, man. All right, guys, we're going to move on to the next question. Just aware of the time and jeez, like, how long have we been going for? What time did we start? 7 o'clock, right? Yeah, jeez, man. It is a marathon session that we've gone through today. All right, let's go through this one here. So with this next question, what we've got here is we've been asked to find an expression for the area. So we've not been asked to, we're not solving it. We just asked for an expression. So basically, we've got between pi over k and 0 for sine kx dx. That's what we have. So we're going to integrate sine kx. We're going to get negative cos. No, we're not going to get negative cos, are we? Yeah, we will. Negative cos kx. And of course, divided by the differentiation of the bracket. In this case, is kx. So we're going to get k. And we don't really need to worry about the plus c. Just leave it out. Come on, man. And that's between negative pi over k and 0. So putting this out, we're going to get negative cos k times pi over k divided by k minus negative cos k times 0 over k. So we've got negative cos of pi over k plus cos of 0 over k. Now cos of pi, negative cos of pi, negative cos of pi. So negative 1 over k plus 1 over k, and it's going to give us 1 plus 1 over k is just 2 over k. So grades wise, merit for 2 over k, correct integral gets you and achieved. Now, not really, Oliver. Whenever you're doing definite integrals, you don't need to worry about the k. One over k minus 1 over k method. I'll be interested to see that, Lou. All right, guys. Last question for the night. I am about to lose my voice completely, but we'll try and get this last one, and then we're done. Hey, fun times. Here we go. Negative cos pi as positive 1. Yep, that's still right. Ayush, what you did was correct, because negative cos pi is 1. I did cos pi on my calculator, which gave me negative 1. So this part here is negative 1, and the negative is still outside there. That's why I get negative 1 as positive 1 there. It's all right. All right, so last question. I guess the first question that first thing we've got to figure out is, this is 2015, right? 2015 Dougal. So the first thing we got to actually figure out is these 2 points right here. So to figure out those 2 points, we need to put both of these equations equal to each other. So we've got negative x squared plus 2 equals x cubed minus x squared minus kx plus 2. Now, normally, if we didn't have a k, we would just put this in the graphics calculator and get the points out. But unfortunately, with this question, we actually have to rearrange to get, we actually have to rearrange to get whatever those 2 points are. So I've got negative x squared, which I can cancel out. Positive 2 and positive 2 cancels out. So what I'm left with is 0 is equal to x cubed minus kx. So 0 is equal to x times x squared minus k. So here I've got x is equal to 0, or x squared minus k is equal to 0. So we're going to get x squared equals k, and x equals to plus or minus square root of k. Remember that when you take a square root of a number, you're going to get the positive version of it, which is square root of k, and you're also going to get the negative version of it, which is negative square root of k. So, yeah, unfortunately, this is like one of those questions where we've actually got to figure out what the shaded region for A is, and then figure out what shaded region B is, and then prove that they're both the same. So the first thing we're going to have to do is, so I'm going to do 0 and negative square root of k. So we're going to do the top minus bottom part. Like, I think that's what we do for finding area between 2 curves. So in this case, for A, we've got the cubic that's on top. So we've got x cubed minus x squared minus kx plus 2. Take away the quadratic, which is negative x squared plus 2. So I'm going to work that out first. So, and that's between 0 and negative square root of k. We've got x cubed minus x squared minus kx plus 2 plus x squared minus 2 dx. See what we can get rid of. Get rid of the x squared, get rid of the 2's, and what we're left with is just x cubed minus kx. So integrate this. We got x4 over 4 minus kx squared over 2, and that's between 0 and minus square root of k. So don't have to worry about the 0 part, because when I substitute 0 in the, that's just going to be 0 minus, now here's where things get a little bit dicey, but it shouldn't be too bad, negative square root of k to the power of 4 divided by 4 minus k times negative square root of k squared over 2. So this is going to give me k to the power of 4, no, not 4, 2. So it's k squared over 4, and then minus k squared over 2. So still going to keep going here. I've got k squared over 4 minus 2k squared over 4, because I want to make those the same denominator. And I've got negative k squared over 4, and negative of negative is going to become positive k squared over 4. So now that's zone A right there. Yeah, it is. It is a lot of work for a merit, man. Like, geez, you got to do 2 parts for a merit. Now, this is not an E question, Andrea. It's like, yeah, it's like finding one area, and then now I got to do the same thing for the other one between square root of k and 0. And I've got parabolas on top, so it's negative x squared plus 2 minus the cubic. Jeez, talk about making me work for the last question. Square root of k, 0. I got negative x squared plus 2 plus, no, minus x cubed plus x squared plus kx minus 2 dx. Oh yeah, no, it'll cancel out. I know that for sure, but it's just annoying. It's still going to get the same, the weird thing is you're getting the same equation, but just minus. So we've got negative x cubed plus kx dx. Integrated, so we're going to get negative x to the power of 4 over 4 plus kx squared over 2, and that's between square root of k and 0. So we've got negative square root of k to the power of 4 over 4 plus k times square root of k squared over 2. That whole thing is going to be 0, and what you guys will notice, k squared over 4 plus k squared over 2, negative k squared over 4 plus 2k squared over 4, k squared over 4. Lemon annoying. Nah, it doesn't work like that. I mean, they have the same region, but it's like, I don't think I can just do it with the k's and the, like, yeah, that was a freaking annoying question. That was like almost 10 minutes for that question to try and do. But yeah, guys, look, that is it. 3 hours session today. Jeez. I think that's the longest stream that I've done in like one hit. I know, right? Like, that would have been like so much more. Yeah, they're meant to be equal, you think. So you're supposed to get k squared over 4, k squared over 4. That was the question. So now that's why I say to you guys, like, look, read the full paper, see if there's a proof excellence question, and see, like in this question, right? If you look at the excellence question, I know it looks complicated, but it's show that. So whenever a question actually says show that, it generally means that you can probably prove it. And I would actually go, well, if it's a proof question, am I willing to risk 10 minutes doing the proof question? Because if I get the proof question right, then I know I'm guaranteed 8 points, which means I don't need to worry about the merit questions or the achieved questions. Now, Stella, we started at 7, because my son went to sleep pretty early today. If you still need to use compound angles, yes, you probably will, Sam. It's always good to have that in your artillery. So guys, tomorrow, just a bit of a heads up about tomorrow. It's like tomorrow we're not going to be doing a tutorial at all, but rather I will go back to my notes and just kind of point out to you guys where you need to go for any kind of questions, all right? Because like trying to do questions on, how do I say, trying to do questions before the night of the exam, it can get a bit crazy, it can get a bit tiring as well. And to be honest, like 3 hours today, I'm shattered. Like need to shut my eye for a few hours. But if I don't see you guys tomorrow, good luck for your exams on Tuesday. Read the question. I can't say this enough. Read the question and mark out which questions you want to attempt first. If it's easy, just get it out of the way. Like, don't be like putting the hard questions first, because then you start getting a bit of pressure and you start realizing, okay, maybe you don't have enough time, and then you start making silly mistakes. So keep that in mind, yeah? Like, just make sure you guys attempt all the easy questions, even if it means jumping between papers. It's like, just make sure you do the easy questions first and then come back to the other ones. Oh, don't think it's end, Andrea. I think the coolest thing is like when I get to see you folks come out into the world, and you know, on the odd occasion I've met students of mine from here, and if you guys do see me around, just come and say hi. And you know, even like what Pix did, coming back um, before, just to say hello to people here and just kind of encourage, it's really cool. And you know, you guys are always welcome to come back and say hi at any time, because I think the level 1s are not going anywhere, and the level 3s are not going anywhere too. And I'm glad to help you, Lou. All the best, man, and we'll do, yeah. It's all good, Ayush. It's no worries, Tanisha. Tanisha, have a good luck. Good luck. Yeah, good night, team. Get some sleep as well, guys. Don't like do like all-nighters on for the final exam. It's not really healthy. You need some sleep. Most important thing is sleep. Absolutely, Lou. Like, you know, I'll tell you what, I've actually failed 5 years of uni before I even got my act together. They were about to kick me out of uni. Like, are you sure you want to study? And I'm like, yeah. So, yeah, that was good hack, Jonathan. I think I'll, when I do end up making that video, I will try and, you know, credit to you for that. Because that was such a cool little, neat little question you asked, which made me think differently. Or is it, I'll chuck it up, give credit to Jonathan. Watkinson, right, Watkinson. No worries, Jang. That was 2AE, right, Jang? From this paper? I think it was. You were talking about question 2E from differentiation. Good night, Roseanne. Don't stress too much, especially not about Simpsons or trapezium rule. If you can get those merit questions, don't even bother with Simpsons or trapezium rule. God, what a waste of time would that be for the calculator. ESS. All right, guys, that's me today. I will catch you guys finally for tomorrow, just for some good luck words. No worries, Campbell. Spread the message around, man. Like a lot of people, a lot of year 11s only found out about my channel like last week. Feel free to spread them around, and yeah, I'll keep that in mind, Jang. If I get some time, I'll see if I can work on it later tomorrow afternoon or something like that. Have a good one, guys. Good night and sleep well. It's that awkward moment where I'm trying to find, like, how do I end this? There we go.